Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Okay, so for today's class, we are going to proceed with permutation and combination. We are focusing on permutations under the subtopic for 4.1.22, 3 and 4.13. Okay, let's proceed. So our objective for today's lessons are: first, at the end of the class, you should be able to determine the number of permutations for n different objects taken R at a time. And then, you should be able to determine the number of permutations for n objects involving identical objects. And the last one, you should be able to solve problems involving permutations with certain conditions. Okay. So, permutations. Permutations is used to find the number of ways of arranging a given number of objects in which the order of arrangement is important. The order of arrangement is important. Okay, so permutations involve arranging objects. Like for example, if we need to arrange numbers from 1, 2, 3, 4. So 1, 2, 3, 4 is not the same as 1, 2, 4, 3. It's not the same as 1, 3, 2, 4. It's not the same as 1, 4, 3, 2. Okay, so permutations is basically about arrangement. When we talk about permutations, we are talking about arrangement, number of arranging. Okay, arrangement. Okay, next. Okay, we are going to look on permutations of n different objects taken R at a time. So this is the formula that we are going to use, NPR, in which P defines as permutation. NPR is equals to n factorial over n minus r, the whole thing factorial. Okay, let's explore. Okay, consider we have the word bertuah. Okay, we have B, we have E, R, T, U, A, and H. So basically we have 7. B, E, R, T, U, A, H. So basically we have 7 alphabets. Okay, suppose we want to arrange only 4 of these letters. Okay, n equals to 7, but take only 4. So our R equals to 4. Okay, so find how many arrangements that we can find, how many ways. So first of all, okay, so this first of all, what we need to do is we need to draw 4 boxes. Because of what? The boxes is for the 4 alphabet that we are going to choose. Okay. So for the first box, from bertuah we have 7 choices, which are B, E, R, T, U, A, or H. Okay, so that is why the first box is 7. So we put 7 here. Okay, and then we for the first box we have picked 1 letter. Okay, and then for the second box, which is for the second alphabet, so how many choices do we have? Of course, from 7 we will have 6 choices here. And then we pick the second alphabet. And then we go to the third box. Okay, the third box is for the third alphabet. So how many choices do we have after we pick 2 from 7? So of course we have remaining of 5 choices. The same goes to the fourth box, which gives us only 4 choices. Okay, so how many ways? Okay, how many ways By using multiplication rule, which you have learned from the previous class, by using the multiplication rule, the number of possible ways is 7 times 6 times 5 times 4, which gives us 840 ways. 840 ways. Okay, 840 ways. Okay, so the number of permutations for 7 different objects, taking 4 objects in which before n equals to 7 and this is r equals to 4, each time can be represented by the notation of 7p4, because before we said that the formula is npr, in which npr is equals to n factorial over n minus r, if I'm not mistaken. Okay, so that is why 7p4. Okay, next. Note that 7 times 6 times 5 times 4 can also be written as 7 times 6 times 5 times 4 times 3 times 2 times 1. Because of what? We are talking about n factorial. 7 factorial is the multiplication from number 7 until number 1, decreasing. Okay, decreasing from number 7 multiplied with the consecutive numbers but in decreasing manner. Okay, so that is why 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1, which is 3 factorial. Because of what? Because of this. Okay, we said that NPR is actually equals to n factorial over n minus r. Our r is 4. That is why 7 minus 4 we get 3 factorial. Or we can say that, oh, this is the remaining alphabet. From 7 we pick only 4, so remaining will be 3. Okay, can you understand? Okay, so we can say that, oh, 7p4 is equal to 7 factorial divided by 7 minus 4, which is 3 factorial. We will have the same answer, which is 840. Okay, simple, eh? Okay, next. Let's look at example 1. 3 students chosen from 7 students are to be seated in a row. Okay, 3 students from 7 students. So we can say that, oh, this 7 is n. 3 students are the students that we need to pick. Okay, in how many ways can this be done? Okay, before I say, okay, prepare your boxes. Okay, so how many boxes do we need? How many people do we need to pick? 3. So prepare 3 boxes. Okay, so for the first person that we are going to choose, how many choices do we have? For the first person, of course we have 7, because we have 7, the total students that we have. So the first pick must be picked from the 7 students. Okay, so now we pick 1 and then we go to the next student, the second student. So how many students do we have remaining? Of course 6. And then the last person that we are going to pick, how many choices do we have? Of course 5. Okay, so basically this one, this is for the first student. Okay, and then the next one, 6 choices to pick the second student. And then the last one, 5 choices to pick the third student. So basically, it is also known as 7P3 because from 7 students, we need to pick 3 students. We need to arrange 3 students. So basically, the answer will be 210 ways. Simple, right? Okay, simple, right? So I hope you can understand this one. Okay, we go to the next example. Okay, Zakiah wants to buy 3 pictures to decorate her new house. She has planned to arrange. Okay, clear, arrange. So we are talking about permutation. Okay, so permutation and PR. Okay, she has planned to arrange the chosen pictures in a row at the dining hall. There are 10 different pictures available in the shop. How many different ways does she have? Okay, so what does 10 represent? 10 represent N. Okay, N equals to 10. How about 3? 3 is number that she need to pick. So R equals to 3. And then the first step, draw your boxes. How many boxes? How many do you need to pick? 3. Okay. So the first pick, of course, the first pick, how many choices do you have? So you have 10 pictures. And then you pick one. And then you go to the second one. So how many pictures left? We have 9 pictures. And the third picture that we need to pick, how many choices for that? 8 pictures. See? Okay. So the first pick, we have 10 choices. Okay. And then the second pick, 9 choices. The third pick, 8 choices. So if we need to find the number of ways, of course, those boxes, those values in the boxes, we need to multiply them. Okay. Or we can say, oh, this is from 10 pictures, we need to pick, or we need to arrange, we need to pick 3, right? We need to pick 3. So we can say, oh, this is 10P3. Why do we use P? Because we need to arrange them. We need to arrange them. Okay, arrangement. So when we talk about arrangement, we are dealing with permutation. Okay, so we have 720 ways or 720 ways. Okay, this is similar to before. Okay, let's look at example 3. Okay, calculate the number of 4 digits that can be formed from the digits 2, 3, 4, 5, 6, 7 and 8 without repetition. Without repetition. So we cannot use number 2 thrice. No. Each number, each digit that we have, we need to use it only once. Okay. So how many numbers do we have? So 2, 3, 4, 5, 6, 7, 8. So we have here N equals to 7. So how many digits do we need? We need 4 digits. So R equals to 4. Again, like I said before, 1, 2, 3, 4 is not equal to 1, 2, 4, 3. It's not equal to 1, 3, 2, 4. When we arrange the numbers. Of course, we use the same number, 1, 2, 3, 4. But when we arrange, the number becomes different. Okay, so when we deals with it, when we deals with this kind of situation, we know that, oh, this is permutation. Okay, permutation. So we are dealing with NP R. Okay, so of course the first step, the boxes, how many boxes? 4. Okay, for the first box, the first pick, of course, how many choice do we have? We have 7. And then we pick 1. And then the second box, we have another remaining 6 choices. And then the next one, another 5 choices. And then the last one, another 4 choices. So basically, okay, this is for the first pick, 7 choices we have. The second pick, we have 6 choices. The third pick, we have 5 choices. And the last pick, the fourth one, we have 4 choices. So the total number of ways, we multiply 7, 6, 5, 4. Okay, multiply all of them. So basically we said that, oh, this is 7P4. Okay, either you use your calculator, multiply 7 with 6 with 5 with 4, or you can also use the calculator. You press 7 and then press button NPR, which is shift division, if I'm not mistaken, division. Okay, and then you press 4, so we will have 840 ways. Okay, so this is simple. Okay, let's look at permutations of n objects involving identical objects. Okay, involving identical objects. So the formula is n factorial divided by a factorial, b factorial, c factorial, in which a, b and c are identical objects. Okay, let's look. What does it mean by identical objects? Okay, let's explore first. So, if let's say we have 3 cards, which the cards is from the word upper, so we know that we have 2 A's and a single P. 2 vowels A and a single consonant P. Okay, so how can we arrange? Okay, the activity asks us to draw the tree diagram, and then based on the tree diagram, list all the possible arrangement of the letters. How many arrangements are there? And then when A1 and A2 are the same, what is the number of arrangements? What method can be used to find the number of arrangements for words involving identical letters, such as the letter A in the word apa? Okay, so let's look at it. Let's dig in. Okay, so when we draw the tree diagram, so actually, if the first letter is A1, so the second letter is either P and A2. Okay, let's say if the first letter A1, the second letter is P, so of course the third letter is A2. The same goes to if the first letter is A1, the second letter A2, so of course the third letter is P. So the remaining is the same process. So we say that, oh, from the tree diagram we have the arrangements of A1, P, A2, and then A1, A2, P, P, A1, A2, P, A2, A1, A2, A1, P, and A2, P, A1. So basically we said that, oh, we have 6 arrangements for this situation. Okay, for the cards upper, so we have 6 arrangements. Or we can say that, oh, we have 3 cards. So the first pick, we have 3 choices. Okay, we have 3 choices. And then the second pick, we have 2 choices. And the last pick, we have only 1 lah. Okay, only 1 card remain. So that is why number of arrangements is 3 times 2 times 1. So we said 6. Or we we can say that, oh, this is 3p3 because we have 3 cards and we need to pick 3 of them. So that is 3p3, which means 3 factorial. So 3 factorial give us 6. This is the case when we said that, oh, A1 and A2 are different. However, when we talk about alphabets, okay, alphabets, no matter what, upper, A is still A. We can say that A1 and A2 are the same because it is the same alphabet. So, when A1 and A2 is equals to A, where 2 arrangements are considered as 1 arrangement, 3 arrangements are obtained, namely APA, AAP and PAA. So, let's look at it, okay? So, this one, okay, let's use, okay. So, A1PA2, A2PA1 is considered as APA. A1A2P and A2A1P is considered as AAP. Meanwhile, P1A2 and PA2A1 is considered as PAA. So this is what the statement means. Okay, we consider the A1 and A2 is the same because it is the same alphabet. Okay, so instead of we have 6 arrangement, when we talk about A1 PA2 is equal to A2 PA1, so we consider as 1 lah. Kan? So instead of we have 6, we need to divide it by 2. So the arrangement will be 3. Okay, so the method to obtain 3 ways of the arrangement is by dividing the total number of arrangement of letters in A1 PA2 by the number of arrangements of the 2 identical letters. Okay, let's change our ink. Okay, so this form comes from where? So this comes from P equals to n factorial divided by a factorial, in which 2, okay, in which these 2 is the identical objects, in which this case is A1 and A2, which considered as A. Can you follow me? Can you guys? Okay, okay, very good. So, so the number of permutations for n objects involving identical objects is given by P equals to n factorial over A factorial, B factorial, C factorial, blah blah blah, in which A, B and C are the number of identical objects. So what does it mean by, let's say, if I have one more here, or I have this one, Papa, contoh. Okay, so we have two alphabets, 2 different alphabets, in which we have A2 and then we have P2. So we said that A and P are identical objects. Okay, so we said that, oh, we can consider as A equals to 2, in which A refers to alphabet A, and then we can say that B equals to 2, in which B refers to alphabet P. So when I said what is the number of ways for this situation, so we said that, oh, the number of ways is n factorial divided by A factorial. Okay, remember we we have two identical object here, which is A and B. So we have A factorial and B factorial. So 4 factorial divided by 2 factorial, 2 factorial. So we have, bukan ni, 4 times 3, 12, 24 divided by 4, we have 6. 6 arrangement. Okay. Okay, this is if I were to add another card, which is P. Okay, let's move on. Okay, example 4. Determine the number of ways to arrange all the letters differently for each of the following words. A, Muslimah, and B, mathematics. Okay, for A, okay, so for A, we know that, we have one identical object, which is M. And the number of identical objects is 2. We have 2 M's there. So we said that, we can claim A is equals to 2. Okay, we can claim A is equals to 2. And then N is the total alphabet, which is 8. So, based on the formula, okay, we substitute all the values. So, we can say that, P is equals to 8 factorial divided by 2 factorial. So, our number of ways in arranging the word Muslimah is 20,160. Okay, 20,160. Okay, so let's look at B. So B, we can see that, not even M. We have M, 2 M's, we have 2 A's, and we have 2 T's. Okay, so I can say that, if I refer A as M, so A is equals to 2, B as A, so B is equals to 2, and C as T, so C equals to 2. And then the total number 8, serious lah, 2, 4, 6, 8, 10, 11. Okay, typo So this is 11. Okay, so silap ni Okay, so this is supposed to be 11. So 11 factorial divided by 2 factorial and 2 factorial and 2 factorial. So basically 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, divided by 2, 4, 8. Banyak So we have here 4,989,600. Okay, 4,989,600 ways. Okay, sorry for the typo error. Okay, Okay, so this is the answer. Okay, guys, can you follow? Okay, let's move on. Example 5. There are 5 blue pens and 3 red pens in a container. Find the number of ways to arrange. Permutation. Okay, all the pens in one line. Arrange all the pens in one line. So, from the information, we know that, blue is 5, red is 3, and then the total, typo lagi sorry, total is 8, and then B refers to blue, A refers to red. Okay, so we know that, we need to use this formula. Okay, and then substitute the value. So we will have the total number of ways in arranging all these pens in one line is 56 ways. Okay, nampak? Banyak. Okay, so we move on. Okay, we move on to the last part. Solve problems involving permutations with certain conditions. Okay, so let's explore. Consider 7 objects. Okay, we have 4 circles and 3 triangles. Suppose all the above objects are to be arranged according to a certain condition. Okay, let's see what is the condition. Okay, if each circle and triangle must be arranged alternatively. Okay, so how many ways do we have? So of course, when we want to arrange alternatively, so they must be next to each other, right? Okay, so since circles is more than triangles, which is 4, so of course circle must be in front, and then followed by triangle, the first triangle, and then the second circle followed by the second triangle, and then the third circle followed by the third triangle, and then the fourth circle. Okay, so we know that circle we have 4 and triangle we have 3. So just like the boxes, okay, let's say this is the boxes. Okay, let's say this is the boxes. Okay, because we use box right before. Okay, let's say this is the boxes. Okay, the first box must be circle. It cannot be triangle. Okay, because triangle is less than the circle. So the first box is the circle. So how many choices do we have for the first circle? Exactly, we have 4. Okay, and then we go to the second box, which is the first triangle. How many triangles do we have? Of course, we have 3. And then we go to the third box, in which the third box is the second circle. Before, we have picked one circle. So for the second circle, how many choices do we have? 3. The next box, we are talking about the second triangle. So we have picked before the first triangle. So how many triangles do we have for the second triangle? 2. And then the next box is the third circle. So we have picked 2 circles before. So from 4, we have another 2 circles. So this is 2. However, the triangle is the last triangle. So this is 1. And this is 1. Okay. So there are 4 factorial, which is 24 ways to arrange 4 circles. Of course. This one, this one, this one is 4 factorial. However, for triangle, we have 3 factorial. Okay, so by using multiplication rule, okay, this one, okay, darab kan, we multiply each other. So by using the multiplication rule, we can also say that, this is 4 factorial times 3 factorial, in which 4 factorial is 4 circle, 3 factorial is 4 triangle. So we will get 1, 4, 4, the same thing. Okay, that is why you need to draw the boxes, because the concept of the box is concept for multiplication rule. It is easier for you to understand. Okay, let's look at example 6. 3 men and 3 women attending a meeting are to be seated in a row. Find the total number of possible seating arrangements. Permutation. If each man and woman need to be seated next to each other. Need to be seated next to each other. Okay, so it might become like this. Okay, first we know that men 3, women 3. So the arrangement might be like this. So the first person is man, followed by woman, followed by man again, and then woman again, man again, woman again. Okay, so the same thing for this part. We know that, oh, for the first person, the male person, we know that, oh, this is 3 choices. Okay, this one 3 choices. Okay, women, for the first woman, of course we have 3 choices too. And then we pick the second man, so we have 2. For the second woman, we have 2 choices. And for the last man, of course, this is 1 and this is 1. So basically, by multiplication rule, we said that, oh, we multiply all these. Okay, 3, 9, 9 times 4, 36. So we have 36. Okay, this is for this case. Okay. But also, you need to remember, this is one of the arrangement. Or it might be this case. Woman comes first. The first pick is woman, followed by man, and then followed by woman, followed by man again, followed by woman again, and then followed by man. This is also considered as another arrangement. Okay, so the multiplication rule is still the same, right? It's still the same. For this one, still 3, 3, 2, 2, 1, 1. So we have another 36. That is why we said that when we talk about possible outcomes, when we have more than one possible outcomes, we said or, and or will relate to addition. Okay, so basically we will have 72 ways. We will have 72 ways. Or we can also say that, oh, this part, I can see that, oh, this is 3 factorial for men, and then this is 3 factorial for woman. So this is man, and then this is woman. And why does times 2? Why does times 2? Because the case, the first will be man, and then the first will be woman. Okay, so that is why we have the same answer as this one. So remember, you need to consider all the possible outcomes, all the possible arrangements. Okay, let's go on. Okay, another condition. If all the circles are always together, okay, the circles need to be together. As if when the objects need to be together, it is represent, or it is described as you are tying these objects so that they become one. That is why this become one place because we tie them together. Okay, so this become one place, one. And then this, one box, one box, one box. So how many boxes do we have? 4 boxes. Okay, we have 4 boxes. Instead of, initially we have 7, but since circle, we need to make it together, so we tie them together, sit at the same place, at one place. That's why we have 4 boxes only. Okay, so there are 4 factorial ways to arrange a group of circles and 3 triangles. Of course, this 1, and then this is 2, and then this is 3, this is 4. Okay, like this. Okay, we have 4. Okay. Okay. And then there are 4 factorial to arrange among the group of circle. Of course. Okay, this is 4 factorial. And this is for circles and triangles. However, for circles, okay, we have peach, orange color, green, we have blue. Okay, so maybe the first one peach, or maybe orange first, and then green, and then blue, and then P, or maybe green first, and then orange, and then peach, and then blue. So this one, since we have 4 here, we have another 4 factorial only for the arrangement of circle. For this part, it can be another 4 factorial just to arrange circle. But this factorial is to arrange circles and triangles. So that is why, by using multiplication rule, the number of possible ways is 4 factorial for circles and triangles times 4 factorial only for circle. So we have 576 ways in arranging them. Okay? Okay? Okay, let's look at the next example. Example 6. 3 men and 3 women attending a meeting, the same question, but this case, the 3 women must be sitting together. Okay? So before, we have 6 chairs, but now, the 3 women must be sit together. The 3 women must be sit together. So we are tying these 3 women to sit at the same chair, as described as like that lah. I describe it like that. Okay, so how can we visualize this? Okay, so basically like this lah. So these 3 women sit at the same space, and then this is the man. Okay, so for this arrangement, we have 4 factorial only to arrange man and woman. But, okay, why do I say this? Because you need to remember the arrangements for all of this. This is only one arrangement. Maybe we can say that, oh, maybe this is man. This is man 1. This is man 2. This is man 3. And this is our women. Or maybe, oh, this is man 1. This is our women. This is our man 2. This is our man 3. Or this is man 3, or this is man 2. So we have another arrangement also. Okay. But what I want to say is 4 factorial here is for arranging man and woman. But you need to remember, we have this one. We have this one. Okay, we have maybe this one. This is woman 1, woman 2, woman 3. Or maybe women 2, women 1, women 3. Or maybe we have women 2, women 3, women 1. So this case, okay, for this case only, so we have 3 factorial only to arrange women. Okay, 4 factorial to arrange man and woman, but 3 factorial only to arrange woman itself. Okay, so how many ways do we have for this case? So we have 4 factorials times 3 factorials, which is 144. Okay, again this 4 is man and woman, but this 3 is only for women. Okay, I hope you can follow. Okay, let's look at another situation. Okay, another situation. If circles and triangles have to be arranged in their respective groups. Okay, so like this. So circles and circles, triangles and triangles. So we say that, oh, this is 4 factorial, only for circle. And this is 3 factorial, only for triangles. So in arranging this one, so we have this one 144. But we can also have another arrangement. This is one circle in front. Or because we can also have the situation in which the triangle will be in front. So this one. So this is 3 factorial. And this is 4 factorial. So when we multiply, we also have 1 for 4. So since we are considering 2 situations, in which the first situation, the circle in front, and the second situation, when the triangle in front, so we have more than one possible outcome. So we need to add. So we add both of them. So we will have 2, 8, in which this situation is the same as example 5 tadi. Yang mana bukan man woman. Apa tadi? Okey. Sama yang darab 2 tadi. Okey. So boleh Okay, next. Example 7. Find the number of ways to arrange 5 employees A, B, C, D, and E from a company at a round table if A and B must be seated together. So A and B must be tied up. So dianggap we consider as one place for A and B. Okay. So how many places do we have now? So we have only 4 places. Okay, 4 places. Okay. So previous class we know that in order for us to find the number of arrangement for round table, so we need to use this one, n minus 1 factorial. So since we said that A and B need to be together, so we have our n now is 4. Okay, n now is 4. Okay, so when A and B are seated together, they are regarded as one. Okay, jadi so from 5 chairs, we have only 4 chairs now. Okay. Then the number of ways to arrange one unit of A and B and 3 others is 4 minus 1 factorial. This formula. Okay. This formula for round table. So let's look at the description, the illustration. So, okay, see, AB is being tied together. So we said that, oh, this is 1, 2, 3, 4. Okay, the same goes. Okay, the same goes like that. Okay, this is when A in front. A, B, A at the front. But at this point, B takes the lead. B in front. Okay, so we have 2 situations. Okay, the first one when A is in front B. And the second situation when B is in front A. So the other alphabet we just put anywhere lah. Okay. But our reference is at AB. Okay, our reference is at AB. Remember, when round table, we need to have reference point. Okay. Okay. So, 4 minus 1 factorial, we will have 6 ways. Okay, 6 ways. Okay. A and B can interchange among themselves. Okay, this is what I said before. The first case is when A in front B. And the second case is when B in front A. Okay, so we can see that, okay, this is case 1. Case 1, A front. Okay, so we have 6. Case 2, B in front. So we have 6. So total we will have 12. So that is why A and B can interchange among themselves into prime. Okay. A, B or B, A. So this is considered as 2 prime, which gives us 2. Okay. However, in arranging them tadi, so n minus 1. Okay, so nak katanya this is n minus 1 factorial for that round table, and then times 2 factorial for arranging A and B. So we have 4 minus 1 factorials times 2 factorials. So 3 factorials times 2 factorial will give us 12 ways. The same thing. Okay. Okay. Okay, next. Example 8. 5 letters from the word Brunswick are to be arranged. Arrange. Permutation. 5 letters. The number that we need to pick. R equals to 5. R equals to 5. And then Brunswick. How many alphabet? B-R-U-N-S-W-I-C-K. 9. Okay. What is the number of possible arrangement if they must begin with a vowel? Okay. Begin with a vowel. So this is our condition. Begin with a vowel. The first alphabet must be a vowel. Okay, so from the question, we know that, oh, we have 2 vowels, which is U and I. And we have consonants, 7, B, R, N, S, W, C, K. Okay, we have 7. Okay, so we need to arrange from 9, we need to arrange 5. Okay, from 9, we need to arrange 5. So basically, we have 5 boxes. right? 5 boxes, right? So for this case, we have condition, right? So we need to settle the condition first. So the condition states that begins with a vowel. So we need to put the value at the first box because that is the condition. So this must be vowel. Wajib vowel. So for the first box, we need to pick vowel. So how many vowels do we have? 2. So put 2 here. Okay. So put 2 here. And then the rest of it, just follow. Okay. After you satisfy the condition, and then go to the next one. Okay. Go to the next one. Okay. So basically we have 9 alphabets. So we have picked 1 vowel. So the other boxes, we don't care whether it is vowel or it is constant. Okay, we don't care because the condition just said that the first must be vowel. Other than that, it's up to you. Okay, so for the second box, we have how many choices? So we have another 8. So put 8 here. And then 7, 6, 5. So that's how we do it. Okay. Okay. See, the first letter must be a vowel. So fill in the value for the condition first. Okay. Vowel there. Okay. So the next one. What? Okay. So this is for this one. Okay. So this one. Darab. Multiply. So basically 2, of course 2 must be there, and then 8 and so on and so forth. So we can say that basically it is 2 times 8p4. Okay, because this part is actually 8p4. Okay, so we will have 3360 also. Okay. Okay guys. Can you follow guys? I hope you can follow. Okay, I hope you can understand. Okay. Okay, next. Example 9. How many 4 digit even numbers? Okay, digit even numbers can be formed from the digits 2, 3, 4, 5, 6, 7, 8 without repetition. Okay, so this one 1, 2, 3, 4, 5, 6, 7. So this is N 7. So this is R 4. And then our condition, we have 2 conditions. First, even number. And then the next one, without repetition. But without repetition ni, basically we need to use all the digits once lah. So it doesn't matter sangat. We know that it means that all the digits need to be used once. But the main point here is even number condition. So of course we have 4 boxes. So how can we form an even number? Even number 2, 10, 100, 122. How can we know, this number is an even number? Basically, okay, even number is a number in which the last digit can be divided by 2. The last digit can be divided by 2. So, the most important thing, this box first. You need to fulfill this box first. Okay, this must be even. So, must be even. So, what choice do we have? Even 2, 4, 6, 8. Therefore, if we choose that box, if we fill the last box first, so how many choices do we have? Of course, 4. And then the other 3 boxes in front, does it matter what number do we choose? It doesn't matter at all. Because for a number to be an even number, what matters is the last digit. The last digit can be divided by 2. Okay. So even number must end with even digit. Okay, or divided by 2 lah. Basically, even numbers must be divided by 2. So of course, if a number can be divided by 2, of course the number must be even lah. So that's why 2, 4, 6 or 8. So fill in the value for the first condition. So the first condition, what does it mean? The last box. So here 4. Why does it 4? Because 2, 4, 6, 8. 4 choices. And then, fill in the first one. Okay, fill in the first one. Okay, so from 7 numbers, we have picked one number which is even at the back. So we go to the first box. So we have another 6 choices. So here you are, 6. And then the second box, another 5 choices. And then the third box, another 4 choices. So by multiplication rule, so supposedly we said that, oh, this part is 6b 3. From 6 we must pick 3. Okay, times with 4. 4 for what? For last digit even. So we will have, our answer is 480 with. Okay guys, remember, when we have questions involving conditions, okay, we need to satisfy the condition first. Fill in the box with the condition first. Only then you can fill in the other boxes. Okay, so evaluation time. So I prepared you with 3 questions and discuss the answers with your teacher. Okay, so homework as usual. Okay. Last but not least from me, guys, a man is like a fraction whose numerator is what he is and whose denominator is what he thinks of himself. The larger the denominator, the smaller the fraction. So, renung-renungkan, tenung-tenungkan sehingga termenung. Okay. Good luck and all the best. So I end up my session with Assalamualaikum warahmatullahi wabarakatuh and peace be upon you. Thank you so much.